Hello everyone, today I'll be presenting utilization of Polinsar data for snow water equivalent and snow depth estimation. This work is done in collaboration with Monash University, IIT Bombay, and CSRE. Snow water equivalent is used to determine amount of water in the snowpack. Snow water equivalent measurements are useful to hydrologists and river forecasters. It provides an estimate of how much water is on the ground that can be potentially run off into rivers and streams. It is especially important in the Indian Himalaya where the water availability during the summer months come from snow that falls during the winter. Its retrieval at high spatial and temporal resolution is required for water resource management, weather and avalanche forecasting, and climate study. Snow water equivalent is measured by field instruments, snow pillows, active passive gamma radiation sensor, pressure sensor, aerial markers, and GPR, and automatic weather stations. These methods are limited to small areas as they are labor intensive and fails to capture spatial temporal variation on snow water equivalent over a large scale. The solution is to use remote sensing techniques. Now, optical remote sensors are used to map snow cover, but they cannot be used to calculate or get an estimation of volumetric property of snow, and they are limited by cloud cover. Passive micro remote sensors are used for snow depth, snow water equivalent, but they provide very coarse resolution in kilometers. So the only solution is active remote sensing, particularly synthetic aperture radars. The Himalayan topography is complex. Snow is an important water resource in this area, and improved snow water equivalent retrieval at high spatial resolution is required, but the lack of dense automatic weather station data are not available, and that creates a challenge of estimating snow water equivalent and depth at high resolution, spatial resolutions. So in this presentation, I'll be discussing about utilization of Polinsar data by static TerraSAR-X data for snow depth and snow water equivalent estimation. Dhundi Observatory is located in Kulu district of Himachal Pradesh, and it is operated by SASE and DRDO. It is located around 3,000 meter above mean sea level, and this is considered as a study area and site because we have conducted field campaign and we had access to this area. We have implemented the algorithm by using the data collected in 2016 January month, and in addition we have conducted field campaign in 2017-18 to check the variation in the parameters conducted on the field. The algorithm utilizes by static TerraSAR-X and dynamics data in descending mode, and it comprises of two sections, A and B, data processing and data analysis. Data processing deals with creation of T6 matrix and calculating the Polinsar coherences. Using TerraSAR-X data, snow density is retrieved in step A. Step B deals with establishing the relationship between HV polarized Polinsar coherence and in situ snow depth measurements. This relationship is tested for 8 January and 19 January. Finally, the snow depth is inverted from Polinsar coherence, and snow water equivalence is retrieved by multiplying snow depth and snow density retrieved in step A. The snow density estimation is summarized in figure 1. Figure 2D shows the data that is used in the analysis, that is 8 January and 19 January. Figure 3 shows the relationship between HV coherence and snow depth for these two dates. Figure 1 shows the inversion results for snow depth, snow density, and snow water equivalent for the two dates, that is 8 and 19 January, top and bottom. The subset of the glacier portion is shown in figure 2, where the square box highlights the glacier ablation and accumulation zone. It is noticed that the algorithm was able to detect the changes in snow depth, and we see that there is a reduction in snow depth in ablation zone. There is no change in snow depth in accumulation zone. The RMSC in SD for 8 January and 19 January is 7 centimeter and 5.48 centimeter respectively, and it is 2.02 centimeter and 1.48 centimeter for snow water equivalent. This approach has a potential of developing into operational algorithm, provided the such experiments, such data is implemented with other mountain ranges, and with the snow-tail data also it can be implemented. And to generalize, we need more field measurements. Thank you.